the way I think about it is reducing it, whether it be an image or text, to some set of numbers that capture the essence of that text or the essence of that image. And it could be as simple as traditional features, right? Maybe image processing features like corners or, color or, some other attribute. But neural nets provide a great way to reduce it to a set of numbers that actually carries some meaning. And, to give an example, I often give a demo. As Vishnu knows, I have a dog, Zeus, that I love. And I think he's cute. So I take his picture and I go find his brothers and sisters, I call it, on the internet. And what I do is I go to Flickr, I download, thousands of images, and I find the image that most looks like him. And what I did to do this was I took the picture of Zeus, right? And I passed it into a neural net that was trained to identify the difference between animals. It was trained to identify dog versus cat versus bird versus elephant, right? And so this neural net was trained to do that classification based on images. And I break apart the neural net, if you will, and I take the last fully connected layer. And that last fully connected layer is, a bunch of numbers. It's 1,000 numbers, approximately 1,000. And those numbers capture in some way the essence of what Zeus, who Zeus is, insofar as the neural net was trained to distinguish cats from birds, from elephants, from dogs. It captures what makes Zeus different than those other animals. And that representation, those 1,000 numbers that, capture what's different about Zeus from those other animals, turn out to be very good at also finding other dogs that look like Zeus. So if the numbers are close, then it's a good chance that the dog looks a lot like Zeus. And if the numbers are distant, it's a good chance the dog doesn't look like it, or maybe it's an elephant, right? And when we say that the numbers are close, then we get into, okay, how do you measure close? And that's where we get into vector geometry. And we think about, you can do the Euclidean distance, you could do a dot product distance, you could do a cosine distance. And these are all just different distance metrics of how we say that two sets of numbers are similar or dissimilar. And in that way, we find, I used cosine. No, I didn't use cosine. I used dot product similarity. And I found the vectors closest, and they corresponded to dogs that looked a lot like Zeus.